Welcome back to our series on alkyne reactions. Now, we're applying that concept to alkynes. Alkynes, with their CC triple bond, have two pi bonds available for electrophilic attack. This means they can react once to form a vinyl halide, or react a second time to form a geminal dihalide. Our focus in this video is the addition of HCl to the terminal alkyne, propyne, dissolved in dihalide, and understanding the Markovnikov selectivity throughout the process. Starting with propyne and one equivalent of HCl, we expect the first addition to yield a vinyl chloride. Following the Markovnikov rule, the chlorine atom will attach to the more substituted carbon, C2. This forms 2-chloropropene. When a second equivalent of HCl is added, the addition repeats. Again, the chlorine atom adds to the sp2 carbon that already holds the first chlorine. The final product is 2,2-dichloropropane, a geminal dihalide. Aside from the possible formation of a pi complex during alkyne hydrohalogenation, the overall outcome matches that of alkene hydrohalogenation and can be understood by referencing the alkene mechanism. Stage 1. Formation of vinyl halide. Step 1. H addition and pi complex formation. The Cl atom's high electronegativity polarizes the HCl bond towards Cl, leaving the hydrogen electrophilic. The electron-rich pi bond of the alkyne protonates that hydrogen. It is highly unlikely that the relatively unstable secondary vinyl cation, which has a stability comparable to a primary carbocation, forms during this process. Stereospecific experimental results, although not universal, indicate that the reaction can proceed via formation of a pi complex. When an internal alkyne is used as the starting material, many experimental observations for the addition of one equivalent of HCl show the formation of a transaddition product. Given these findings, it is reasonable to consider the pi complex as a pre-association complex, or an early transition state. We will therefore explain the mechanism based on that assumption. Step 2. Nucleophilic attack. Within the developing pi complex, H bears partial positive character and Cl is relatively negative. Partial positive charge localizes, preferentially, on the more substituted carbon, C2, which stabilizes it better than C1. In CH2Cl2, a weakly ionizing solvent, attack typically occurs within the same polarized pi complex. Cl is relatively delta minus, while H is delta plus, and C2 is attacked in a concerted or very rapid stepwise fashion, only under strongly ionizing conditions, or with abundant free Cl minus, would an external chloride attack after full ionization. The first stage product from propyne is the vinyl halide 2-chloropropene. If the substrate is an internal alkyne, such as 2-butyne, anti-addition of H and Cl commonly predominates. Note that EZ naming follows CIP priority. Even though H and Cl add on opposite faces, the higher priority substituents, Cl and CH3, can end up on the same side, giving Z, 2-chlorobutene as the major isomer. Stage 2. Formation of geminal dihalide. Step 3. Second H addition. The pi electrons of the 2-chloropropene attack the polarized hydrogen of HCl. Due to the inductive withdrawal effect of the chlorine atom, the pi electrons are less available than in a simple alkene. This reduction in nucleophilicity means this protonation step influences the overall reaction rate. The major intermediate pathway in stage 2 likely involves formation of a transient, ion pair-like cationic intermediate. With that assumption, we will describe the mechanism in terms of this carbocationic pathway, while still acknowledging possible pi complex contributions. The transient positive center at C2 is partly stabilized by alkyl hyperconjugation. Any stabilization from chlorine lone pairs is weak and is generally outweighed by chlorine's negative inductive effect. Furthermore, if free Cl- is sufficiently available, or under more ionizing conditions, rapid trapping can occur. In CH2-Cl2, the capture often proceeds within an ion pair or tight complex. This enables rapid trapping of the short-lived secondary carbocation. Step 4. Second nucleophilic attack. The chloride ion attacks the secondary carbocation. Completion of the CCl bond formation yields the geminal dihalide, 2,2-dichloropropane, as the final product of stage 2. Let's summarize. Stage 1. Formation of vinyl halide. Step 1. H addition and pi complex formation. The alkynes pi electrons attack the polarized hydrogen of HCl to form a pi complex. Step 2. Nucleophilic attack. Within the same pi complex, the adjacent Cl- rapidly attacks the more substituted carbon from the backside, yielding the vinyl chloride. Stage 2. Formation of geminal dihalide. Step 3. Second H addition. The pi electrons of 2-chloropropene protonate, the hydrogen of HCl, forming a transient, ion pair-like cationic intermediate. Step 4. Second nucleophilic attack. The formed cation is swiftly captured by Cl-, either internally or externally, ultimately producing 2,2-dichloropropane. Let's organize by keywords. The halogen atom adds to the more substituted carbon of the multiple bond. A temporary association between the electron-rich pi bond and the electron-poor H of HX, often acting as an early transition state in non-ionizing solvents. The addition of one equivalent of HX yields a vinyl halide, and the subsequent addition of a second equivalent of HX yields a geminal dihalide, where both halogens are on the same carbon. To wrap up, those who wish to deepen their understanding of alkyne hydrohalogenation and its related reactions are encouraged to study the following topics. If this video was helpful, we'd really appreciate it if you could share it with others. See you in the next reaction.